Good evening. The first thing we're going to do today, I'll say the first thing, the only thing I'm probably going to do tonight, is I'm going to build this board up, which has been waiting for a while. Been asked for this by one of my daughter's band members, and finally getting round to do it. It's a fuzz pedal for a guitar, and the board comes from guitarpcb.com. Barry, who runs it, is a very good supplier, always top quality boards and very reasonable prices. You can't argue with them at all. So that's what I've done. Now, because I actually downloaded the build document quite a while ago, I did actually try the circuit out on breadboard, and I made sure I had all the components in stock, and I did try it out, and it is actually a very nice warm sounding fuzz pedal. So what I'm going to do is I'm going to basically transfer everything that's on here onto the circuit board, and then solder it up, put it in the box, and test it out. So we'll be back shortly once I've got the soldering iron and everything ready, and we'll see you all soon. Thank you. Okay, the other thing I'm going to do, which I didn't mention before, this is also another guitarpcb.com product. This is the triple pole wiring board, and basically instead of having your standard switch with the poles and lots of individual wires coming from your input and your output, these boards just make things a whole lot neater. Very simple to build. You basically just plug them in, and away you go, really. Space for a common anode LED, space for the current limiting resistor. You have your power coming in to the socket here, and it just makes things a lot easier and a lot neater. You can still run the LED and the power from the main board. It's personal choice, but I actually like using these. It just makes things so much nicer, so much easier to do, and the fact that everything is labelled up means that you can set things up, and it's just very easy to do. So I will be using one of those. And okay, right, now here we are back again. We've got everything in the board. If I just get my I use my scalpel just to do the pointing. You've got your 9-volt in socket, which is your standard guitar size socket. Fits pretty much every power supply on the market. This here is just sticky tape, double-sided sticky tape with the backing left on. The reason I've done that is so that the board doesn't short out the back of the pots. It could if it was pushed down, which is one of the reasons why this capacitor is laid slightly to the side, just so there's enough clearance in the case. As you see, that one's slightly high, but that will sit in the back panel of those will sit in the back panel, but that one just seems to be a little bit higher. Maybe it's been molded slightly differently. This is the board, and as you see, the only active component on the board will be the IC. Now, the reason I use a socket here is so that if ever I feel like changing the IC for a different type of op amp, I can. It is known that different types make different noises. The 4558 sounds different from the TL072, which is what I'm going to use in here, the TL072 that is. And there are various 8-pin dual inline op amps that you could put in there, and they all sound slightly different. I could even put one of the new surface mount ones on an adapter board and slot that in there, and that might sound completely different as well. I haven't actually tried one of those in a fuzz circuit yet. Going further down, you've got, this is a ground connection which connects the two grounds of the sockets together, and as you see, here is the PCB on the back of the switch, which switches it on. The LED here, your current limiting resistors here, and your connections down here. You've got your 9 volts, and you've got the board output, which is from here to here, and then you've got O, which is your output, which goes back to the socket. So this is your output socket, this is your input socket, and again, this side you've got your input and your input to the board, all switched by this. Now, as you see, using this allows you to have very little wiring between the two. You only need to supply this with 9 volts to basically get the LED to light, instead of having all of the switch lines going to this part of the board here. As you see, 4, 5 and 6 would be the center 3, which would just control the switching of the LED, which would normally go here, and the current limiting resistor would normally go in this point here, but again, because I've got it on this board, I don't need to have it all over here. 9 volts comes in from here, and as you see, I've used 28 gauge wire, very, very small wire, because I can. Basically, I've got sort of meters and meters of the stuff. Let me just grab a roll. There we go. It's single core wire, and I know it's got 2 different sizes on it, but it is actually 28 gauge wire, this one, and as you see, there's rather a lot of it there, and I've got several rolls of this, so I might as well use it up on projects like this. It's very, very versatile. You can actually flex it quite a lot, and it also means that you can tuck everything out the way so that it looks nice and neat and tidy. So if I actually turn it over, that is what the pedal looks like at the moment, without any of the writing on it. I haven't decided what to mark on it yet. What you have here is you've got your bass and your treble, and you've got your gain and your volume controls, and yeah, they're just straightforward standard. I went with these knobs. They seem to fit the panel better, and they give me space to actually I don't quite know what I'm going to do, whether I'm going to write on here, stencil it, or maybe even just mark on the knobs. I don't know. I haven't yet decided how I'm going to label it, but what I will do first is I will plug the IC in. So if I take it out the breadboard where it was tested, so we can go with that. Just make sure it's the right way round slightly, so that they'll go into the socket much more easily. So that's better. And there we go. That's in the socket now. Then I shall get the base and just rest it on for now, like that. As you see, it sits nice and flat, and put that there. So with that, I will get the scope all connected and set the camera up so you can see the output on the oscilloscope. Back soon. Right, okay, there we go. Set up the test bench. I've actually dimmed the lights. I've changed the position of the camera now. So what you're looking at is the input of the signal generator on the orange cable, and the output is going to the oscilloscope via that oscilloscope probe there. So what I'm going to do is I'm just going to I'm just going to pan up and come out here and zoom out a bit. Right, that's the test equipment that you can see there. If I just zoom in central, that's the signal generator and the power supply. The power supply is just running the lights there. I could actually kill that and reduce the noise. And as you see, here's the oscilloscope. So let's get in as tight as I can on that. Okay, and just fix the camera there. Now, what you can see on the scope, I'm just going to move the microphone. If you get a bit of noise, then that's what it is. Right, okay, so on the scope you can see that currently you have two traces. The top one is the trace from the output of the signal generator, and the bottom one, if I don't kick the tripod, the bottom one is the output from the pedal. Now at the moment the pedal is operating. If I turn it down into the standby mode, you can actually see that both waveforms are actually identical. If I then go back into operate mode, the first thing I'm going to do is I'm going to turn up the output volume. And as you can see, the bottom trace is getting larger and larger and larger, and it actually becomes bigger, quite a significant amount bigger, with a lot of clipping. Let me just reset the scope, go the other way. So that is actually 0.2 volts per division. So we've got 0.2, 0.4, about half a volt there of audio. The other trace is actually 50 millivolts per division, so you've actually only got 100 millivolts going in, and you've got about 500 millivolts coming back out. So it is boosting the gain somewhat. If we back off on the volume, you can see the waveform actually cleans up. If I then go up to the gain control, again the gain control does increase the signal quite significantly. Again, I've gone the wrong way. You can just start to see the clipping at the top of the signal, and that is actually 1 volt per division. So there's 2 volts of audio coming out of there, which is quite a lot. Once I start upping the volume control, not the gain control, as you can see, it really does affect the signal and the shape of the waveform. Right, just to show you how it's working, everything is set to minimum at the moment, and as you can see on the oscilloscope, you're getting just a solid straight trace. So what I'm going to do is I'll turn up the gain. You should also start to hear the tone coming through. It's actually going through a mixer at the moment, and with the gain full up, you've got a slight bit of distortion at the top of the waveform, but nothing too significant. If I bring the volume up, you can now hear it getting fuzzier and fuzzier. And as you see, with maximum gain, you're getting quite a... Let's turn the gain down a bit. With the maximum volume, it is a very, very loud, fuzzy signal. That's probably too much for most amplifiers to take. So if I bring that back like that, and just get a slight bit of distortion on, bring the gain back up, I'm going to bring in the bass control. And as you can see, it's changed the waveform for a slightly different fuzz. And then we'll put the treble in. And that's just added a little bit of a tone. Now if I As you see, the tone doesn't sound clear at all. Let's go back to 440, which is a guitar A string, and clean it up again. As you roll off the gain, you can bring it back down to a normal level signal, and you can clean it up quite well. Then obviously the more signal you put in, you can actually get the fuzz on just the high-end notes. What I'm doing at the moment is I'm just increasing the level into the pedal so that you start to get the distortion. Now hopefully you're picking all this up. If not, I don't know how else I can sort of demonstrate it without a guitarist and an amplifier. The problem is it's now midnight in the UK, and if I turn it up too loud, I'm sure I'm going to get the neighbours complaining. So there we go. That's the 4-track fuzz pedal from guitarpcb.com. Thanks very much, Barry, for sending me that. Very reasonably priced board. As I said at the beginning, I'm going to turn the noise off so that we're just on. There we go. Kill the signal generator. As I said at the beginning, Barry's pedals are very, very economic to build. The actual total cost of building that pedal would be round about the £15 to £20 mark, which when you consider how much you would pay for a boutique pedal is very, very reasonable. You can really adjust them to make them sound more harsh, less harsh. There's a lot of information on the forums, so if you do like the sound of that, or if you do want to try building your own guitar pedals, I'd recommend certainly going to guitarpcb.com and having a look and see what Barry sells, and have a look through all the different types. There are sound clips on there so that you can actually hear them working. Probably a better sound clip than listening to my test set. So give it a go and tell me what you think of the video. If you like it, click like. If you don't, tell me what I can do better, and hope you have a great day. Thanks very much. Bye bye.